I focus not necessarily on Abacus standalone, but primarily on all the integrated simulation tools. So, like V5 back in the day, I did a lot of that. And now it's mostly all 3D experience related. And in particular, I have a passion of bringing the two communities of design and simulation closer together. And, that helps us with the SOLIDWORKS enablement into 3D experience as well, because those historically have been two different kind of communities, but now with the Works portfolio, we're able to bring those two communities a little bit closer together and enable folks with some greater simulation capability. So that's kind of my background.
No, absolutely. And talking about those simulation capabilities, I know we've got a jam-packed session today.
Yeah.
What do we have for our viewers today?
Yeah, so if you've tuned into the series thus far, I've gone through a number of different things. The first one is I did a high-level overview of just kind of bringing everything together, giving an overview of the simulation capabilities on the platform. And then I went into another part of the series of, how the organization of the structure is created, with all the different types of representations that we have. Spent a lot of time there. Today, I'm going to kind of take a lot of the previous sessions that we've done and put it together in a lot more detail, show you a lot more detail in the process. And what I've prepared for you today is an impact analysis on the frame. So we want to just check, is our frame strong enough? And, doing a standard strength simulation is pretty straightforward, pretty easy. But what I also want to show is how easy it is to do some advanced type simulations. And so I'm going to set up an explicit simulation here and show you, how we can do that kind of thing. What I will do is, we had a video before of the bike running into a wall. Everybody knows that it's probably not a good idea to run your bike right into a wall, right? So I'm going to do a jump simulation. We're going to take the bike off a jump and show you that kind of simulation.
That's fantastic. So before we do that, Greg, let me ask you a question. You used a couple of words back there. You used the term explicit analysis. For our viewers, can you tell the difference between the two different types of analysis and where we would be using these two?
Yeah, exactly. And I can get into this a little bit more when I start setting up the scenarios, but we kind of have two main types of simulation. I don't want to call them domains, but different simulation methods that you can use in a scenario. And typically what most people do, 80% of the time, 90% of the time, I don't know, I think 90% of all statistics are made up anyway, but so we typically do implicit, which is so when you're doing standard structural simulation, that's an implicit type simulation, and it's not really time dependent, even though it's nonlinear, and you can use nonlinear materials, and you can use, large deflection, and you can use nonlinear contact and all of this. It's still kind of a implicit simulation that, it goes through and it solves some different steps and it iterates between those and creates a solution for you. Explicit, you can kind of think of as more of a time-dependent simulation. So anytime where the amount of time of your loading is very important, that's when we would use a slightly different solver that's available to us in the platform. So like SSU, that's what's going to enable us to use this explicit sort of simulation. So a drop test, if I'm going to do a drop test of a cell phone or a jump where that I'm having that impact, I need to know what that time dependency of that exactly is that's where I'm going to use like an explicit simulation.
Right. Okay. That makes sense. So more for like you mentioned, impact or drop and things like that, like simulation of those sorts.
Yeah. I mean, if you want to sum it up in 2 words, yeah, you bet. So.
Got it. Perfect. Well, I'm excited to see what we have and how to set up this in explicit study. So please take us home, or please take us to the journey.
Yeah, let's do it. Okay. So are you sharing my screen already?
I am sharing your screen.
Okay.
Actually, let me share your screen right now.
Okay.
Give me one
Perfect.
second. There we go.
All right. So we've gone through this scenario, and again, this young lady, she's not wearing a helmet. We need to get a helmet on her. That'll be for another time. So the whole series, we're going to go through a lot of different types of simulations in the series. I believe the next session, you will talk about that a little bit later, is going to be plastic injection, and we'll go through doing some of that. But today we're going to do strength and structures for the frame here. So I'm going to go ahead and close out a PowerPoint. You are a very lucky audience today, because that's all the PowerPoint I'm going to show.
Yes.
Yeah.
About our audience, by the way. So for our new viewers, we like to keep this session very interactive. So please put your questions in the question channel, and we will do our best to answer as we go through this through this demonstration. Also, please give us a like and a subscribe on our 3D Experience Works channel. This keeps us going forward, and we're able to bring a lot more cool content to you guys. So please go ahead and give us a like and a subscribe.
Yeah, right on. Thanks. Okay, so here we are in SolidWorks. I showed some different ways that we get the SolidWorks information into 3D Experience. If you need more details on that, refer you to some previous sessions. But I'm going to go ahead and do it. So here we are in SolidWorks. With the PLM services, or a UES, we get this embedded sort of 3D Experience data manager in here. And, again, there's a few different ways to bring this into 3D Experience. The method that I showed last time was you just basically highlight the item that in UES here that you want to open up in 3D Experience. And you can simply just go up to the compass and then pick which application in 3D Experience you want to open it in. Or we can be real fancy, and I can do a drag and drop from SolidWorks to my 3D Experience blank tab session, and voila.
Wow, that's easy. I like the drag and drop.
Yeah, me too, man. It's pretty sweet. Yeah, it's funny doing these presentations. Somebody's like, hey, why didn't you do the drag and drop? And I'm like, yeah, I don't know. Why not? It's pretty interesting. The things I take for granted that's in the software that I just don't think of to show. Okay, so I'm going to probably be talking pretty fast. I got a lot to show, but again, ask me some questions as we go along here. But what we want to do, again, we want to prepare this frame for an impact study. And as I look at this frame, if you refer back to my helmet sort of presentation, as I did some shell meshing, I did some solid meshing, I did some TEP meshing. So I did a lot of different meshing, but those different meshes were on different parts. And so even though we were doing some mixed meshing, those were on different parts. And as I look at this frame here, it's a thin tube frame. And so when I first look at this as a simulation person, how do I want to do this tube? Typically, if I mesh this entire geometry with tetrahedrons, to get the kind of stress resolution I would need, I would have to have a minimum of 2 elements through the thickness here. And, if I had 2 elements through the thickness on that tube, wow, that's going to make so many elements on this model. And, it's just not going to kind of give you that bending forces and bending moments that you kind of really need to represent the displacements and the stresses. It'll probably be a little bit over stiff. So let me shell mesh the whole thing. Well, if I think about shell meshing this whole thing, this is an e-bike, and here I have my battery compartment, right? And that's kind of a big, solid, chunky block. So if I was to shell mesh this whole thing, what happens with this section here? So that wouldn't be a good approach for this section.
Correct.
So what do I do? Well, we have the capability to create a mixed mode mesh. And what I'm going to do is I'm going to go through and show you how I can shell mesh and solid mesh this single part. I could break this up into an assembly, but it's kind of not really an assembly. It's kind of still just one part, and that's how the part was built in SolidWorks. And so I want to use this exactly the same way that the part was built in SolidWorks. So first thing I want to do, or I need to do, is I need to prepare the geometry. I need to prepare this geometry for shell meshing and solid meshing. So what do I need to do? So as I look over here at the geometry tree, I can see that, okay, here's the geometry that came through in SOLIDWORks, right? It has the do not enter sign. So I am not able to change anything under here because we are retaining the geometry authoring tool inside SOLIDWORks. So any change I make in SOLIDWORks to the geometry is going to get pushed through here, and it's going to update this section of the tree.
That's great. Great. Yeah. That's a great point you bring, because let's say if we are running the simulation and we want to make some changes, let's say we figured out like, something is not right and we make some changes. Yeah. So what you were saying is you can just kind of automatically push these changes, these SOLIDWORks changes, CAD design changes into our simulation tool.
Right. So I would come back here to SOLIDWORks, I'd make my changes, and then to bring those changes into the software here, it's pretty easy. I just need to go to the Tools tab, and then I hit Global Refresh, and my new geometry is here. Yeah.
That in sync for SOLIDWORks to say in sync with this tool, that's great. That saves a lot of time for setup and redoing your, the whole setup again. So yeah, quite a nice feature, I would say.
Yeah. Thanks. Yeah, it's pretty awesome. But I want to do some things. Let's say I want to mid-surface this. Well, I could do that on SOLIDWORks, but if I do that on SOLIDWORks, I'm changing the SOLIDWORks geometry. And if I have some drawings and things like that, how's that going to affect my actual SOLIDWORks geometry? So when I think about preparing a part for simulation, I like to leave my original geometry alone. Like, let my SOLIDWORks geometry be my SOLIDWORks geometry, and now let's create some construction geometry for simulation. And I showed this a little bit in one of the previous sessions. So what I need to do is I just come here and I insert this thing that's called the abstraction shape. And I went through, all the different representations in a previous session. So basically, I'm just creating a new representation here. And what I will do is I will take this initial geometry here that came over from SOLIDWORks, and I will copy it. And now here in this abstraction shape, I'm going to paste it with a link. Okay. So what I did is now this points back to this. So any changes that happen in SOLIDWORks get pushed to here, and any changes here get pushed down to here. So it's kind of a unidirectional workflow. Right now, I actually kind of have two things visible out there, so I want to be very careful what I pick. So I'm going to hide this original one. Sure. Now we can just see the shape of this abstraction shape. So now what I can do is I can start to do some geometry manipulation of this. So let's do a partition. So I'm going to create a partition, and I want to, what volume do I want to partition?
And when you say partition, Greg, is this we're just splitting up the chunky body compared to the shell body? Is that what we're partitioning?
Right. So if you think of like a block of cheese, right? If I have a block of cheese, and if I take like a wire and I cut a wire down through the block of cheese, and then I smash the cheese back together, right? Well, it kind of has this suspended plane in the middle of the cheese, right? It's still one big block of cheese, but it's got this suspended plane where I've got two different volumes of the cheese. And for meshing, what that allows me to do is I can mesh one volume, one partition of that a certain way, and I can mesh the other volume or the other partition of that a different way. So maybe on this side, I do a coarse mesh, and on this side I do a fine mesh. And at that transition, because it's still kind of mathematically one volume, it's going to merge all those nodes and elements right in that transition. So you're going to have all these really small elements, hits that transition, and then it's going to kind of expand out to the bigger elements. Yeah, and I'm gonna do that same thing here. So I'm picking this surface as a partition, and what that's going to do is it's going to put that slice right through my geometry. So we can now this section down here is actually kind of partitioned off from the rest of it. And I'm going to create another partition right up here, same kind of thing. And zoom in just a little bit more. I'm going to pick that surface, and you'll see that I'm saying infinite. So what that does is that takes that shape of that surface and mathematically represents it as infinite. So there's no edges to it. And then if I hit OK, we can see now that my part has been partitioned right across here.
Perfect.
And then my other one was partitioned right down here. So now in reality, I have split up my volume into multiple partitions. So I have a partition out here, I have a partition down here, and then I have a partition that kind of gets the backside of the frame.
Great. And the reason why we're doing this, Greg, is to be able to apply shell mesh some places and solid meshes some places.
Right.
To do that, right?
Yeah. So my ultimate goal is to create a solid mesh of the battery compartment and then a shell mesh of the rest of this.
Brilliant.
Yeah. So here, inside the abstraction shapes, I'm going to create another little placeholder called a geometrical set. And this is one of the other great powers that we have in 3D Experience. This was just geometry stuff. None of this was actually designed, except for the partition, was for simulation. These are just CATIA geometry features that we get because we're using the platform. So it's awesome.
So again, Greg, that's a very good point you bring out. With the platform, we have this major umbrella that we're all under, right? And now we have access to all these amazing applications that lie within that umbrella, and we can use that application in simulation. So this overall is just, this whole umbrella that we're under is just very cool.
Yeah, we get like the data management, right? We just get all of this, Of course, we've kind of tailored some of it specifically for simulation or whatever, but wasn't originally, I wouldn't say developed for simulation. It was developed for designing parts in a PLM lifecycle, and we just get this. It's just this added functionality. Whenever we think of simulation or the platform, people are like, "Yo, what are the physics? Can I do this type of simulation? Can I do that type of simulation?" Okay, fine. That's a great thing to talk about. But there's all this other stuff that we take granted for that we get from the platform. That's just awesome. So with this geometrical set, this is just a personal thing that I do is I like to have all of my solids in a part body, and I like to have all of my surface entities, so all the surfaces that I'm going to shell mesh in a geometrical set. You don't have to, but I just like to keep things organized. It lets me hide and show things a little bit easier. It just kind of in my mind, I just like to have those two things separated. So what I'm going to put in this geometrical set is I'm just going to do an extract, and I'm going to pick this surface here, and I'm going to say, whoops, I'm not going to say that. I'm going to say tangent continuity. So I picked that surface, and then it just kind of grabbed all of those other surfaces there. And then I'm going to go ahead and do that same thing with this side and pick OK.
So all the surfaces that are tangent, it's automatically picking it for you?
Yep, it's picking all the surfaces that are tangent. So
you're telling me I don't have to single click on all those to select them all?
I mean, you can.
No, with that tool, no, thank you. I mean, that's a fantastic tool.
Yeah, job security, the surface picker guy, whatever. But yeah, it'll take all those tangent surfaces. And so now I have these two different ones here. I've done this in two different sections just for discussion sake. I could have used this one called multiple extract, and I could pick this one and I could pick this one and select OK. Let me hide this. And now it's all one, and you can kind of see that it sewed together. It merged that little split right there.
Correct.
In reality, if I was to simulate this, that's probably what I would have done. But let me just leave it there. I'll just leave it there for now. And I'm going to do some other stuff because I want to show you some things specific about meshing where I have two different surfaces. And this is the great thing. This is the other great thing about you know, the 3D experiences, I have all these surfaces out here. Like I have all these different, you know, kinds of things for the surfaces, and I can just play hide and go seek all day long and just basically keep them around as construction and just use those ones that I need. And it doesn't really matter. Okay, so there we are. We're done kind of prepping this. Now let's go ahead and let's create a mesh. Let's mesh this thing. So how do I mesh it? So I just need to simply go up to the compass, and then I go find the mesher. And in French, structural model creation stands for meshing. So you guys learn a little bit of French today.
Love it.
Yeah. Because I'm doing this in a very manual way, I'm just going to create an empty fem. Standard will automatically flavor. You know, it'll take a look at my model and it will try to predict the meshes that I want to put on the model. Because I'm doing a mixed mesh, it's probably not going to do that. But if you just have a solid and you're just going to mesh it as a solid, I use automatic at that time. But because I'm doing a very special technique here, I just wanted to go ahead and do empty. So the first thing that comes up here after I hit that form is Contributing Shapes Manager. Basically what this does for us is I'm telling now the software which portions of this geometry structure do I want to be able to have selectable when I'm creating my meshes. I could go ahead and select everything in here, but I know that I'm not going to mesh anything in the e-bike frame up here. All of my things that I'm going to mesh is down here in this abstraction shape. So I'm just going to turn on abstraction shape. That helps me pick only the geometry that I want to use. And I need all the help. I pick wrong stuff all the time, right? So I need as much help as I can get.
Absolutely. I agree with you. And with these tools, you know, the software just makes our life easier.
Yeah. So let's mesh it. Let's do some meshing. All right. So I've gone to the meshing tab, and now I just go to Surface Quad Mesher, and I can either pick it visually out here, or I can pick it from the tree. So let's go ahead and do that. I'll say 5 millimeters. I'll just I'm going to turn that off for now, and I'll select mesh.
You know, while it's doing that, Greg, I'm kind of curious to know from our viewers, like how many of them use shell mesh and how many of them use solid mesh, and maybe a hybrid of the two in their assemblies and stuff. So all our users, if you guys and girls use meshing and you use the SOLIDWORKS or use the shell mesh and the solid mesh, please give us a +1 in our chat. And if not, I mean, this is some really cool information that Greg you're showing to us. And I'm also tying it to the previous episodes that you've shown, and everything is sort of tying in. It's just like step by step what you're doing next. So for our viewers that have probably, like, you know, if they missed the previous episodes, please go to our 3D Experience Works channel, and over there you'll see all the previous live episodes that we have done. A lot of great information in there. Please go ahead and grab, see these videos and see what Greg is showing to us. Yeah, this is great information, man.
Yeah, cool. Thanks for that. And, you know, we should probably point out, this session is not going to be 30 minutes. I don't know if we said that at the beginning. Our other sessions were slated for 30 minutes, but I got so much stuff I want to show you guys. I'm going to go overtime a little bit, so we'll probably go at least 35 minutes or so, just to kind of, you know, let you know that if you have to leave, don't. Come back, or you know, if you have to go to the bathroom, go take off, go to the bathroom, and come back. I'll still be here.
Come back quick. Yeah.
Anyway, so I've meshed the left side. Let me go ahead now, and we're going to go and mesh the right side of the frame there.
And you're doing this live. You're meshing this live.
Yeah. I don't like pre-canned videos, you know, for whatever reason. So I meshed both of those. And as we look, because I had two different surfaces there, let me hide the geometry. I told you a lot of hide and show today. Right where that partition was, the mesh doesn't really line up very good. And if I go look at my checker and I go look at a free edge checker, I'm getting free edges on the ends of my shells where I expect them, but I have this free edge here. And so if I was to solve this, what that means is that's not connected, right? It's gonna sit and do this. The reason it did that is because I was not very careful in one of my selections on the mesh. And what I want to do is I want to toggle on this capture. And by default, I'm not sure if this changed yet, but I think by default, sometimes this shows up as 0. A 0 here is kind of a null. So I'll always have a value in here, you know, much less than the size of your mesh. But so if I put 0.1 in here, my mode is condensation, which is again French for merge nodes. And then we have here apply on. By default, it has default. And what that's going to do is that's going to merge with any other meshes that are out there. Sometimes we may not want this to merge with all the adjoining meshes, and we may want to pick specifically which mesh to merge that with. So if I had already meshed this bottom one here, for whatever reason, if I didn't want it to merge here, but I did want it to merge here, then in this, I could just come over here and pick which mesh I want it to specifically merge with. So let's go ahead and remesh it, click OK. Now if I zoom in and have a look, it looks a little bit nicer. It did a pretty good job there. And if I do my free element edge checker, it's all good, right? Yep. Now, if I had just gone ahead and let me play hide and show here. Let me hide these. Let me hide these and show this one.
Greg, your French words, you know, these are becoming a little popular. I think we should continue with these ones.
Yeah.
Also, our viewer Sri Krishna, he mentioned in our question for, like, you know, if they use shell and solid mesh, they say he uses mostly solid mesh but hybrid sometimes, but rarely shell. Do you what about you? Like, what do you think? So, when you are do you try to tend to stick to mostly solid meshes, or do you actually kind of go into shell as needed?
Yeah, you know, it's all about the shape of the geometry for me. Our TET meshing and our solving capabilities are incredible for TETs or hex or whatever you want to use there. Shells can solve much quicker because you don't need as many of them, perhaps. And so it really just kind of depends on the level of detail, resolution, and accuracy in the solution that you're looking for. But for this frame, I would do it exactly like I'm doing it here. I would shell mesh this. You know, I would go ahead and shell mesh this. Now, if we're very, very concerned with the stresses here, maybe this could be another session, but I would go ahead and shell mesh this. And what you can then do is you can extract out those displacement results from the shell mesh, and you could utilize those and apply those in a more detailed mesh. So I could actually kind of come back in and partition out or section out a finer area, you know, whether I'm doing a bracket with some fillets, and then I could TET mesh that, and then I could apply these previous run boundary conditions to that area to get a little bit more detailed results in that area. So, you know, again, it just kind of depends, but for tubular structures, I would typically shell mesh it. And then for, you know, machine stuff, plastic parts, it kind of depends a lot of times what the resolution you're looking for. But so hopefully that answers. So this time I picked this multiple extract, and I'm going to go ahead and mesh that multiple extract. And now once that's done, click OK. And now if I go to the checker, we can see by default there's no free edges on that one. And so that's what happened is when I did that multiple extract, it actually sewed those two surfaces together to make them one surface. And so in the geometry area, I don't have to worry about that. And so that's probably what I would do if I did this in real life. But, you know.
Greg, this is fantastic. Like, so these things that you're kind of showing us, I had no idea of this. So I'm learning so much from you. And just from you showing these picks and clicks, and I can imagine the same thing for our viewers as well. So guys, if you want more content, want to have access to more content like this, please like and subscribe our 3D Experience Works channel. And we're happy to bring not just this, a lot of different cool simulation and SolidWorks content to you guys. So please like and subscribe.
Yeah, and absolutely, this is for you guys, right? I'm not giving this presentation for myself, right? I mean, maybe
I already know this.
Yeah, this is for you guys, and we have a series of topics that we already have planned to show you. But I mean, if you want something specific, let us know. Give us a comment, send us an email. Let us know, and then we can do some topics on that as well. More than happy. So yeah, for sure. Okay, I've still got this one piece left over here. I'm gonna hide and show. So I've still got this solid bit out here. So that's kind of weird, right? So here's that solid thing that I have out there, and I still have the surface out there. So I'm showing you how I can have multiple pieces of geometry out there at the same time. But when I'm creating my meshes, I'm specifically picking those individual areas that I want to mesh. So the next thing for me to do is I need to mesh this with a solid. So how do I do that? Well, I'm going to come down here to the TEP mesher, and I'm going to go ahead and you can see it's picking the boss over here. As I pick it graphically, it picks the boss, but it picked everything out there. It picked that entire thing. What I can do with this is I can refine, and I can say keep only. And if I pick this and this, those are my two partitions that I made. And so now when I go ahead and mesh that, it's only going to mesh those two partitions. I'm going to leave on this capture. And now when I go ahead and mesh it, it's going to take just a few minutes here because I've got a pretty small mesh. So I want to kind of match the two mesh sizes between these pretty close. I don't think it's going to take half an hour. I've heard that's one of the hardest things to program in software is that time prediction thing, right? So there's my solid mesh. Now, if you remember, I'm playing hide and show here. So if I go ahead and show those, now what do you think is going to happen? So now as I zoom in here, we can see that those all got picked up really nice and clean. And if I go to my checker, look at that. I have no free edges except where I expect them. So these are all merged, and these are all merged, and that is now one congruent, condensed, node merged, whatever that you want as a whole mesh.
That's amazing.
Yeah, that's pretty slick. So some of the expert users out there might be like, Greg, hey man, you have a shell mesh and you have a solid mesh. Shell meshes contain 6 degrees of freedom, 3 translation, 3 rotation, and solid meshes only have 3 degrees of freedom, translation only. So what happens? So as this thing, gets loaded up, what happens to those other 3 degrees of freedom, that rotation? How does that get transferred over to the solid here?
Valid question.
And as a simulation engineer, you kind of need to, this is where experience and knowledge comes into play. You kind of need to know what's going on. And for this model, it's probably just fine right the way I have it, because I have a circular, like a tube structure mounted down to a solid structure. So just by the shape of the geometry itself, I don't have to worry about capturing those rotational degrees of freedom, because that's all going to be taken up in the actual shape of the geometry. Now, if I had something to show you, so if I had a plate, like a block, if I had a block and I had just a single plane come into the corner of that block, if I don't have a way to control that rotational degree of freedom, that it's going to actually act as like a hinge. It's just going to fall. It's going to flop. And so you need to capture that rotation to get that displacement transfer from that shell mesh over to that solid mesh.
Makes sense.
So if you run into that kind of scenario or that situation, underneath connections in our couplings, we have this very sweet shell edge to solid face coupling that will account for that, capturing that rotation. So all I would have to do now is capture that edge and then capture this face down here, and that would create a coupling between that edge and that face to then, you know, take care of that stiffness in that corner there. And obviously, if you're really worried about the stresses and strains in this little joint, that's not the proper way to model it. But it's a perfectly wonderful way to model it to get, you know, your overall stiffness of your whole model. You know, if your stresses are out here that you're most important with. So a lot of time, that's why I would do these mixed meshing, is just to make things solve faster. And then if I'm really concerned about that junction, I will come back and do something different specifically for that.
Out of curiosity, in that junction, is there, so all of these things that we are doing, and Greg, that you're showing, is to blend those elements from shell into the solid, or there's no blending happening? There's just translation of the forces, or
yeah, there's not really a blending. It's just a transfer of the displacements, or the displacements from one to the next. Because that's all FEA is. It's one big spring equation. F equals kx. Really, that's all it is. You have a displacement, you have a K, which is your spring stiffness, and you have a F, which is force, right? So as something moves, or as something has a force, it moves, like F equals kx. So K is basically what we call the hypermatrix file of this. So it's just a big, huge matrix, mathematical matrix, representing how this whole structure is. And as we know from structural mechanics, we can relate F to stress and strain through Hooke's law and some different things like that. So, I mean, that's it. Sorry, that's the hidden black box secret of FEA. It's just one big spring equation. And
now only if all the setups and everything was that easy, right?
yeah, right. That's your 600 level graduate course right there, summed up. F equals kx. Okay, so before I get this ready for a simulation, I just need a couple more things. I've got a mesh. I just need to create some properties for the mesh. So I'm going to go ahead and pick my two shells here. And I just need to apply a thickness to that, whatever it happens to be. So now I have a property for the shells, and I need to assign a property for the tetrahedrons. So for shells, that's thickness and material, and for solid entities, I don't need a thickness because they are a 3D object. I just need to do that so that it knows what material to basically assign to that. That's it. So we've got this mesh. We've sectioned it. We've partitioned it. We've connected it all together, and now I'm ready to put my loads and boundary conditions on here. So what we need to do, if I want to do this explicit simulation, I'm going to go into mechanical scenario creation. Okay. And that's going to go ahead and that's going to create the structure and the hierarchy I need to be able to put my loads and boundary conditions on here. As I showed in some previous sessions, we have, we can create multiple meshes. So maybe if I mesh this all with solids, I could have one femrep for that. I have my femrep here with the mixed mesh, so that's the one I want to select here. And now I'm basically telling this physics simulation which one of those meshes that I want to use. All right, so procedures, I'm going to go ahead and pick explicit simulation. And like I said early on, with explicit, it is time dependent. So in a standard simulation, this number doesn't really mean anything. we always have a 1 there. And what that means is 1 is the end of the step of iterations, 0 is the start, and it's just doing a translation until it gets to 1 is full application of your load, basically. Here, it's time dependent. So do I really want to run this for a full second? I don't really care what happens after the impact necessarily, like a second after the impact, because impacts are so fast. I really only need to have a very small time duration of that. So I'm going to put in 0.02, and there we have our explicit. Yeah, question?
Yeah. So that small time, the 0.02 seconds. Actually, if you think about it, the impact, like you're right, Greg, the moment of impact is very, very, very small. So
yeah,
it is about in the right ballpark.
Yeah, and it could even be smaller than that. I don't know. I just try to start with a number, and then as I solve it, I just kind of watch the iterations to see, if it was too long or too short or whatever. But once you start doing these, you kind of get an idea of how long that duration needs to be for your loading. All right, so we've created this. Let's go ahead and put some boundary conditions on here real quick. We're just going to go ahead and put some clamps on here. We'll clamp the rear axle. That glyph's a little too big. I can't pick anything else, so I'll go ahead and pick that one. I'll pick that one. I'll pick this one. And let's go ahead and pick the head tube up here. All right. Beauty. So now I've created my clamps. What kind of loading do I need on here? Well, I need to apply some kind of loading on here. And what I'm going to do is I'm going to apply a velocity. So, we can calculate that from, some sort of height drop, 1/2 mv squared, with mgh in there, and I can calculate my velocities.
Some potential and some kinematics.
Yeah. Or I could just be like, you know what? I am a wicked mountain biker, and I am going to come down hard, whatever we want to put in here. So I'll put in the velocity. I'll put in the translation related to the global axis. And I think I may have missed telling it what that was actually applied on. So I didn't pick any. So I need to apply that to my.
We were just excited to go fast. So
yeah, I just wanted to go fast. Yeah, see, I was actually going up, so that was. Yeah. I'm glad I came back.
Greg, just to kind of make sure we're in consideration of everyone's time, we've got a few minutes left, so can wrap up and show some results. That'd be fantastic.
Yeah, getting super close. So the only other thing I have left is gravity, man. So we've got some loads, and I want to put some gravity on here. And I'll put it on the whole model. And because I work in, a weird sort of space, Z is apparently not up. So we'll just use -9.81 and this. Here we go. We got some gravity. So I've got my mesh. I've got my materials. I've got my properties. I've got my loads. I've got my boundary conditions. I've got everything set up. I'm ready. I'm ready to send this off to the solver. So I would click simulate and send this off to the solver. But, as any good cooking show that you watch on TV, I have a pre-baked pie for us that I've already gone ahead and cooked the pie. And here we go. And we can savor the deliciousness of this explicit dynamic simulation. So
brilliant.
As we go through, we can look at all the different time steps as it goes through my jump sequence. And there we go. We have an explicit simulation. And so now you can see that my time step was actually a little bit too big. So as you watch, it's coming down, and then at some point it starts to kind of bounce back up. So now we're actually kind of, we see the displacement here is kind of bouncing back up there a little bit. So that's good. That's exactly what I want. I want that impact, and then that slow response of the bounce back up. So there we go. We just jumped our mountain bike, and hopefully everybody survived and wore your helmet.
Yeah, this is great. So can you show some? I'm sure there's a way to animate this to see that how that animation happens. Or there it is.
Yeah, it's just the play button. Just the play button.
How cool is that? I mean, and especially like, you know, if I am working on an e-bike frame or any bike frame, and I want to be able to understand how, you know, this impact works or even how stresses work, I don't have to go and make a bike model. Like I don't have to get a physical prototype done. I can test these things here in this powerful tool, and then finally go make 1 or 2 prototypes and test them, compare the results with my simulation results, and be happy.
Yeah, yeah, especially for that. Like, you know, like different drop, you know, if I'm talking about like a cell phone drop or whatever, different drop heights, different drop angles, all of this. And I think we're going to cover that in a later session, doing some DOE, some designs of experiments where I can set up all these different loading parameters, you know, drop heights, jump heights, rotation angles. We can set all this up and let the software go off and solve this 1,000 different iterations or variations of the design. And then you can go in and predict, you know, that specific one that you want to use. So
yeah, that's fantastic. Great job, Greg. Thank you for all the work. I'll have, and talking about you know, some future episodes that we're going to be looking at. I want to show, you know, so we have another you know, great session for you guys next month on August 23rd, and in this particular session we'll be diving more into how the plastics tool, the IME tool, works in this SimulaWorks portfolio. So super excited to learn how, you know, when we're manufacturing plastic components, I want to understand where, you know, if there's any manufacturing defects that are going to be produced before I even go and make the mold. You know, if I'm going to see some short shots or red lines and things like that. So I'm extremely excited for this episode as well, and can't wait to learn more from you, from Murali, from Zen, and it's going to be another fantastic, you know, episode of Plastics. Again, this is on 23rd August. Again, the same time, 10 a.m. Eastern Standard Time, and yeah, super excited for all this stuff. So, Greg, again, I want to thank you for all the information and all the knowledge that you give us and our viewers, and you know, I'm sure they're thankful as well. I can't wait to use the techniques that you've taught me to actually go into the tool today and set some stuff up. So cool. Thank you again. I want to thank our viewers as well for you know, staying with us this long, and for liking and subscribing our channel, for following our channel. Please continue to do that. That gives us a lot more opportunity to bring a lot more cool content to you guys. So Greg, any parting words for our viewers?
No. Do we have time for questions, or did we cover everything?
Not many questions flew through, so a couple came through. We addressed that. Yes.
Cool.
And
all right.
We're good to go for now.
All right. Awesome. Yeah. Thanks, everybody. And again, you know, if you have comments or questions, you know, just let us know. We're here for you.
Brilliant. All right, everyone. A very happy good morning, good afternoon, good evening, and good night to everybody. All right. Cheers. Bye-bye.
Ciao.